Yeah, as I said again, last chapter is all about one-dimensional motion where you have something moving the x direction or y direction, okay, or the z direction. But then in this chapter, chapter 3, we're going to stress on two-dimensional motion where two directional motions are taking place at the same time, and you have to process that. But before you go to the chapter 3 fully, like before you go into projectile motions and so on, you need to get some foundations on vectors. What's a vector?
It has both magnitude and direction.
Very good. So vector is a quantity that has magnitude and direction. You can write it down. You can write all that stuff down. I'm not going to write everything in the book. A vector, what it is a quantity that has magnitude and direction. Magnitude means the size, and direction means
Direction.
yeah, which way it's oriented. So, how do you represent? Representation of vectors. The pictorial representation is by using an arrow. If you kind of draw an arrow, the arrow is a representation of a vector, and symbolically, how do you represent the vector? You will say vector A. In other words, it's a symbol with an arrow on the top. Now, the arrow on the top need not be drawn according to the direction of the actual vector. It is just a symbolic representation. Now, some books, instead of writing vector A that way, they just make it bold letter, because for printing purposes, So when they write capital A with bold, they are trying to imply that, well, it is not a normal A. It's a vector, it's got direction as well. Some of them have a different symbol on the top. It's mostly for printing ease. Like when you want to type something, typing this is going to be a headache, right? So that is why some of them do that. But normally in textbooks and all that, you'll see a letter with an arrow on the top. That implies it is a vector, kind of trying to remind you that it is a vector. Take care. Because vector additions are not the same as scalar additions. Scalar additions means you just add them, subtract them, whatever. So scalars have only magnitude, no direction, like calorie-wise. I took this in the morning, and then I took this in the morning. So what did I take all together? Just add them up. Because that is just energy. Energy is no direction. So just add them up. Simple. Okay, so simple additions and subtractions is what you have to do in scalars. But vectors, you cannot just add them and subtract them. You have to be conscious of the directional element. Okay? So unless the direction is taken care of, you will not be able to process vectors. So what we are going to do today is to learn how to process vectors. Okay? So vector representation is that, letter with an arrow on the top. And the length of this arrow represents magnitude. The length of the arrow should be representing the magnitude, and the orientation is what tells you the direction. You can ask me any questions at any time. Okay? The length represents the magnitude, and the orientation represents the direction. So if I know there's a certain displacement, so if I say this is 40 meters, now of course 40 meters is not representation of vector. How do I say this vector? It is 40 meters at an angle of 35 degrees north of east. Are you familiar with those conventions? You should be, pretty much. How do you say these angles? You got to say these angles. Now, there's always a confusion. Students kind of, mistake it as east of north and north of east. How many of you are confused on that so far? It's a very common confusion. So writing north of east and east of north, mistaken completely. For those who are getting confused, just read this off as from, and then you'll see how clear it becomes. Instead of off, read it as from. 35 degrees north from east, which means you start from the east and go towards the north 35 degrees. Make sense? So if you just replace, I don't know why it is written as off always, but it actually makes better sense to say from. So from east, go towards the north 35 degrees. Is that clear? So if you're given any direction, like what do you call this one? If I'm going to have a vector like this, what do you call this angle? Yes.
West of south.
West of south. Clear? You see? This angle is west of south, and this angle will be south of west. So that way you should not get confused, because think of this as from the south as you're going towards the west. So towards the west from the south. So west of south. That means west from south. Get it? Yeah, don't make mistakes on that any further. That's it. No excuses on making mistakes. Now I told you that read the off as from, and if you're still making mistakes, that is something. So how do I represent vector A? Vector A is 40 meters at 35 degrees north of east. Finished. You're specifying everything. When you are saying, when you're kind of mentioning about a vector to somebody, you have to mention both magnitude and you can't just say, oh, vector A is 40 meters. That is an incomplete statement. Vector A, you're saying is a vector, and you're only saying the magnitude, right? That is wrong. Vector A is 40 meters, 35 degrees north of east, makes it all clear. And I'll tell you where the angles are preferably to be measured from. You can also write this as the other way around, but I'll tell you why one particular reference point is always good. All right, so length represents magnitude and orientation represents direction. Okay. And then the different kinds of vectors, parallel vectors. What are parallel vectors? Those which have, those that are parallel to each other. So vector A and vector B are parallel to each other. They are the same direction, that's it. Doesn't have to be same magnitude. You can see that this vector is a smaller vector, this vector is a larger vector. So parallel vectors, perpendicular vectors, simply means it's a 90 degrees. So if you have a vector A like that and another vector like that, well, these are perpendicular vectors. So if you're told it's two perpendicular vectors, all you are given is not the magnitude, but the directional part. The angle between them is 90 degrees. That's what is implied. Equal vectors simply means they're both equal in magnitude and direction. So A is equal to B. Opposite vectors implies that is A, opposite vector implies it just is in the opposite direction and nothing else has changed. Nothing else has changed here. They're in the opposite direction. That's it. One is this way. So in other words, A is equal to negative B. Does that make sense? That means if I take negative of B, it's the same as A. That is opposite vector. Unequal vectors, they are unequal either in magnitude. So are these unequal vectors? Yeah, they are unequal. Either in magnitude or direction or both. Okay, then they are unequal. So if you have vectors which are like that way and that way, they are unequal vectors. They're not equal in any manner. So when they are unequal in any sense, magnitude or direction, they're not equal vectors. They are just different, totally different. Even if they are the same magnitude, if they are different directions, then it is unequal. Okay? Any questions on this so far? Good. Now, why we have to consider all these things and then study vectors in detail is because processing vectors is not as easy as processing scalars. I mentioned that already, right? So when you're adding vectors and subtracting vectors, you cannot just do them blindly. You have to be careful of the direction. Like, for example, if I give you, here's one vector, A, which is 40 meters to the east. And then I give you, there's another vector, another displacement. So somebody moves 40 meters to the east. And then he just moves 50 meters to the west. He makes two displacements. One's 40 meters to the east, another one's 50 meters to the west. You can see that, I've drawn this slightly bigger. That sort of sense while drawing should exist. It's not exactly a scale drawing. It's not, but approximately, I'm just showing you that this is slightly more than that. Just to show you that. So when you're drawing vectors, keep the numbers in mind. So if it is 10, then make it smaller. If it is 20, make it a little bigger. You make it different. You don't have to sit and, you don't have to really draw them by scale. That's good, but we don't want to waste time on that. So when you're drawing vectors, even for a rough purpose for solving problems, you do it approximately to scale like this. So it will make better sense later on. So how do you add vectors? So adding vectors. What I'm going to do is basically A plus B. And A plus B will give me an answer, which is what we call as the resultant. R is the resultant. The word resultant simply means the end product, end result. Right? Resultant simply means what is the overall effect of the two vectors combined. Simple. So R simply means what did you get out of the combination of these two? After adding the vectors, what is your end result? That's called the resultant. So it's no big deal about resultant. Don't be burdened about this word. It is just the end result. Okay? The resultant is after you combine them, after you add them, after you subtract them, what do you get as the end result? That's what it is. Now, how do you get this done? What we do normally is by drawing. And when you're drawing this, draw them one after the other. By the way, when you're representing a vector by means of an arrow, this is called the head of the arrow, and that's called the tail of the arrow. So we'll use this term head and tail. Some books kind of say this is a tail, but this is the tip of the arrow. Okay? But head is what I like. Arrowhead. Tail. Tail and head. Makes better sense. Right? If you think of a snake, snake has a head and a tail. Just like that. So head and tail is what you're normally kind of referring to. Not tip and tail. Tip is a word that is also used. It's okay. Which is more heard by you, tip or head of an arrow? Head. Let it be head. So what do you do now? You draw one vector first. Here is my A. That is my A. I draw that. And then what I do is continue my drawing from where I left off there. So I finish this drawing, and from the head of the first vector, I start drawing my second vector. So the tail of the second vector is going to be attached to the head of the first vector. So I'm going to do my second one starting from here, but since it's going this way, I draw it this way. So now this is a head and tail mixed together, so it's kind of cancelled off. Now where is the resultant? Resultant is going to be the ultimate head, ultimate tail to the ultimate head. There's only one tail that you see here. Where is it? And there's only one head, you see. After you join all these things, there's only one head that you see. So the ultimate tail to the ultimate head, that arrow is the result. How much is it?
10 meters.
10 meters to the west. Perfect. So when you are asked for the resultant, remember resultant is also vector, see arrow? You have to say just not 10 meters, but 10 meters to the west. Complete it. So that's something that you need to know. If you are told, find the magnitude of this vector, stop at 10 meters. But if they're telling you, what is the vector? What's the resultant? Then you have to say both, magnitude and? Okay. Is that clear? So the answer for 40 and 50 meter displacements put together is 10 meters to the west. You see, if you're not careful with the directions, you will say 90 meters. So the direction is what makes it 10. 10 is the overall displacement. So instead of going 40 meters that way and 50 meters back again, I could have just gone 10 meters this way. You can also subtract vectors. What is A minus B? A minus B. Let's take the same A and the same B. A minus B. A minus B is supposed to give you the resultant. Now, looking at A and minus B, I can also write it as A plus minus B. Is that okay?
Yeah.
It's the same as addition. The subtraction turned into an addition now. But I'm adding A with not B, but with the opposite of B. Just the opposite of B. Where is the opposite of B?
50 meters.
That is minus B. That's minus B. So what I'm going to now draw is first A, that is that one. That's 40. And then I will attach to it minus B. Basically, I'll cut and paste this right there. So I have to take this tail and join it here, and there it is. So where is the ultimate tail and the ultimate head? Here and here. So join that line. That is the result. And in this case, it's going to be 90 meters to the east. 90 meters to the east. That's the resultant. Okay? Clear? So you know how to add vectors, how to subtract vectors. Now, if the angle is not always going to be 0 degrees, it can be 90 degrees. So, if someone makes a displacement, he goes 30 meters north, and then he makes another displacement of 40 meters east. So I've already joined it for you. You see? You can see that I already joined it for you. The tail joining the head. I've done it already. Where is the resultant? Where is the resultant of these two displacements? Instead of going 30 meters north and 40 meters east, I could have just gone one way, which is the hut. Yes. And how much is this? This is the resultant. Tell me what is the resultant. Is that enough? No. 50 meters is just half an answer. You got to say which way.
50 meters east is north.
You have to tell the angle.
45 degrees.
It's not 45 degrees. 45 degrees means these two should be equal. You can't say northeast. That's wrong. Northeast implies it's 45 degrees.
It's 30 degrees.
60. 3, 4, 5.
Yeah, they're not.
You don't have to memorize anything like that. Take your calculators and find it out trigonometrically. What's the connection between this side and this side of a right angle triangle? This is a right angle. So tan of the angle is 40 over 30. So do this and get me the angle. Use your calculators and discover the angle yourself. Tell me the answer. Now if you cannot find that answer, that is going to be a troublesome thing for future. So the angle is 53 degrees approximately. So how do you say the resultant is 50 meters at 53 degrees. Now where?
East of north.
East of north. So basically it means east from the north, which means my starting is this way. And okay. Now can you say whatever it is, 37
37.
degrees north of east? Can I say that as an answer? Well, it looks like it's okay, but think of more practicality here. Look at this. If I want to reach there, if I want to go to Sam, I have to first make one displacement this way. And then I turn around and go that way, right? So 1 and 2. So I go this way, 3 meters, and then go that way, 4 meters, I'm there. That's the resultant. Now, instead of going that way and that way, if you have to tell me one direction for me to kind of travel to reach there, which direction is that and how much magnitude? So you're going to tell me, all right, don't go east. Turn yourself through what degree? 53 degrees. And then just walk 5 meters and you reach your destination. All right? Is that clear?
Yeah.
So your starting point is here. You're going to direct me from here as to which angle I should start off so that I reach my destination. You can't tell me the angle at my destination. Telling an angle over here is meaningless. You can't tell, all right, you start moving 5 meters such that you reach there at such and such an angle. That is technically not easy. You're not telling anything from here because this is where I'm starting. You give your answer reference to the starting point and not to the finishing point. Make sense?
Yeah.
So giving an answer here, although it's mathematically not wrong, technically it's wrong because you are actually displacing yourself from here to here. You should know which angle you're going to go right in the beginning, not at the end. Make sense? Yes?
So what would we do if they weren't making a right triangle there? Like if 40 was northeast instead of just straight west?
What do you mean? This is not 90?
No, like what would we do if it wasn't 90?
Oh, we'll get there. We will get there and much more. Just understand what I'm telling you right now. Then once you understood this, we are getting more and more. I'll complicate things, don't worry. No. I'll make things easier for you, even complicated stuff. But yes, for some time it'll look like I'm complicating stuff. But yeah, it's okay. Did you understand how to do these things? Did you know how to find the resultant? Did you know how to find the angle? Did you punch it on your calculator and find it out yourself, or somebody told 53 and you accepted it? If that is the case, you're going to get trouble in the test.
I'm a bit shaky on how to do the tangent thing.
Okay,
Like,
here.
how do I input it?
So what you do is, tangent of theta is 40 over 30. So what you need to do when you want to find the angle is, to find the angle, you press second function tan. So it becomes like this on your calculator. And then a bracket opens up. Second function tan. Push second function tan. Because now we know the ratio, we want the angle. If you know the angle and you want to find the ratio, just plug tan of that angle and you get the answer. But here we don't want the ratio. We already have the ratio. We are switching backward. So therefore, press second function tan on your calculator and just put the 40 over 30 over here. Close the bracket, enter, and that will give 53 degrees. And make sure that your calculator is in the degree mode.
It is.
If it is in the degree mode, you get the answer. Getting it?
Yeah.
Now, tan inverse is not the same as 1 over tan. Remember that also. Some actually think that when I write tan inverse, it's like 1 over tan. No. Tan inverse is like working backwards from the ratio to the angle. That's what tan inverse implies. It's not 1 over tan. Okay, is that clear? Any other questions here? Good. So if you have a 90-degree angle, well and good. It's okay. But what if you don't have a 90-degree angle? Then things are going to be totally different. Because you cannot apply Pythagorean theorem straight away. Now, so let's say to find the resultant of vectors, there are 3 different approaches. and I'll show you all the three different approaches. The first approach is called the scale drawing method. So now I'm going to show you the vectors. Here is a vector A, and here is a vector B at an angle of 70 degrees. And here is a vector C at an angle of 40 degrees. And here is a vector D at an, okay, straight down. So I gave you 4 vectors. Now let me put some numbers here so you'll have some references. Suppose I call this 10 meters, and I call this 15 meters, and I call this 20 meters, and this is 25 meters. Approximately to scale. Okay? This is approximately to scale. So, what is A plus B plus C plus D? I'm going to add all the 4, and I want my resultant. What does that mean? I give you 4 vectors. Going 10 meters east, going 20 meters 70 degrees north of west, going 25 meters at 40 degrees, what is this?
South of east.
South of east, and this one is 15 meters south. Making all these 4, my question is, where do I end up? What is my total displacement? So to find this out, 3 ways. The first method is called scale drawing. Now what is a scale drawing method? Scale drawing method is you draw these on paper, on your books, but scale it down. Well, you're not going to draw a line 10 meters long, right? So whether it is meters or newtons or anything which is a vector, you don't want to use them. So you just scale it down. Instead of 10 meters, I will draw a 2 centimeter line. So 10:2. Get it? So 2 centimeters will represent 10 meters for me. So what's the ratio there?
1 to 5.
1 to 5, but remember, I'm changing units as well, okay? Just keep in mind. So here is meters, but I'm going to draw centimeters. So instead of drawing this, I will draw 2 centimeter line. So starting from somewhere, I'm drawing a 2 centimeter line. That is 2 centimeters across. Then what do? I go to B, and this is a 20 meter line at such an angle. So I start from here again, and I draw, how long? 4 centimeters. I draw 4 centimeters at 70 degrees. So from here, I keep a protractor. Scale drawing uses everything. So use a protractor and draw 4 centimeter line. Okay, that is the next one. So this is A, that is B, and then I go to C, and that is a 25 meter displacement, which will be how many centimeters? 5 centimeters from here at 40 degree angle downward. So here is the vector. That's 5 centimeters. So that is my C. And then the last one comes D, which is how much? 3 centimeters downward from here. So it's 3 centimeters downward. That is 2, and that is approximately 3. After drawing all this, then you look at it and say, all right, where is the ultimate tail? Right there. Where's the ultimate head? Right there. Join the line from the tail to the head, from the ultimate tail to the ultimate head. That is your resultant. Now, how do I get the resultant numerically? What you do is measure this length, measure the length of this. And suppose the length of this comes out, let's say, I've almost back. So suppose the length of this comes to 4.8 centimeters. If it comes to 4.8 centimeters, how much does it imply?
24 meters.
24 meters. Is it clear?
Yeah.
So what did I say this was? 4.8 centimeters, yeah. 4.8 centimeters implies 24 meters. So you have the resultant equal to 24 meters because we are scaling it up now. And then, what is the other thing that you need to find out? The angle. So this is our starting vector, so you can actually measure it from there. So instead of telling a person, go this way, go that way, and go that way, and go that way, you can just tell one instruction, which is go 24 meters at such and such an angle. So measure it with a protractor on the scale drawing, and you get the angle. Then you get the answer. So suppose the angle comes out to be 30 degrees or 32 degrees. At 32 degrees, what?
South of east.
South of east. Okay? Now, where do you get 32 from? You just measure it with the protractor. Now, that's called the scale drawing. You can do any number of vectors, you can add them up, all by doing scale drawing. Now, what is the disadvantage of using scale drawing? Anyone? Yes.
It takes a long time, and like you don't draw it right, you don't get the right answer.
If you don't draw it right, your pencil lead itself is like 0.5 millimeters.
Yeah.
So when you're drawing a 2 centimeter line, how sure are you that you exactly drew 2 centimeters? And how sure are you that this angle was exactly as specified here? When you're using a protractor, there's a lot of window for error, right? And also the length of the line, that matters. So if you make mistakes on each of these lines a little bit, this is going to change a lot. And it'll be close, but it won't be accurate. So this method won't give you an accurate answer. Is that clear?
Yeah.
But it will get you somewhere close. So if you are trying to find out where the resultant is supposed to be, you can do this. Suppose it's a multiple choice question where they threw all these things and said the resultant is which way, like A, that way, B, this way, and the size also is shown, And then you're told to pick one of the answers. You don't have to do anything much more than this. Just draw a scale drawing, and you'll see, all right, so that's the answer. Pick it up. But you got to draw the scale drawing to as best as you can. Okay? If you make like random lines like that, which are almost equal, all of them are equal, you won't get there. So if at all mistakes are going to be there, it's going to be a little bit off. But you won't be given. So the answer choices will be like this, that, that, that. So which one is going to be your answer? So you just say, all right, now I can see that it's going this way. So clearly, that must be the option. This is called scale drawing. In future, you're not going to be expected to draw anything with scale drawing. So forget about that. No, don't forget the method. Don't forget the method, but keep that in mind because this is a very important way of estimating where the vector is. Only estimation, not accurate calculations. So this is one method, which is scale drawing. And now we'll go to the calculation method. The next one is called the calculation method, where you find the resultant by purely math. Okay? You're not actually doing any scale drawing, but yes, you can draw any problem. I told you have to draw. But then when you draw, keep that scale drawing in your mind, but you don't have to use a ruler and protractor, but approximation. You know approximately 45 degrees is what. You know approximately what 30 degrees look like, right? So you know how much it is. So just give an estimated drawing. That's very important. So suppose it's like this. The plane takes off. It is on the ground till 50 meters. And then it starts off at an angle. And it goes a certain distance. So that's the problem. So this is my first vector. 50 meters. And then the plane actually starts moving. The plane on the runway, 50 meters, and then it starts off at an angle. So it's starting at an angle. So I can draw these as two different vectors, but I'm going to attach it straight away. So at what angle it's taking off? It's taking off at an angle of, let's say, 40 degrees. And it goes on for 70 meters. Okay? So it went for 50 meters, and then it went for 70 meters at this angle. Now, how do you represent that angle? 40 degrees above the horizontal. That's it. So when a plane is taking off, instead of east, west, north, and all that, you just say horizontal, 40 degrees above the horizontal. If my question is, after traveling this much, where is the plane? What is the total displacement of the plane? So we want to know what is A plus B. You want to know A plus B, which is supposed to be the resultant. Now, since the angle is not your favorite 90 degree, you cannot use Pythagorean theorem. So where is the resultant, by the way? Can you check where the resultant is? Where is the resultant? By scale drawing. So I've already drawn the scale drawing here. So the resultant is this. So that is the resultant. And now your goal is to find out the resultant and the angle. And you know the angle is less than 40. Yeah. Common sense tells you it is less than 40. So if your answer is coming out 75, then you know something's gone wrong in your calculations. So to do these problems, we purely take the help of math. And what math do you need to know to do this is probably known to you. And if you have a faint idea, that's a nice time to review the material. We call it cosine rule. I'll write down, first of all, what is cosine rule? Write down. Cosine rule helps us to find the third side of a triangle, any triangle. Suppose you have a triangle like that. No, remember, I'm not putting any vectors here. It doesn't matter. For any triangle, cosine rule is not meant for vectors only. In any triangle, if you know two sides, it will help you to find the third side, provided you know the angle contained. So write down the statement. Cosine rule helps us to find the third side of any triangle if two sides and the angle contained are known. If two sides and the angle contained are known. Look at this. I know this side. I know this side. And I know the angle contained. You understand what is angle contained? This is the angle contained. You can see the angle contained is smaller. So don't take this as the angle contained. Angle contained is the angle between the vectors or between the lines. So I know this length, I know this length, and I know the angle here. So will that help you to find this? That is cosine rule. If you know two sides and the angle contained, you can find the third side of any triangle. So if I know this angle, and if I know this side, and if I know this side, I can find the third side. If the two sides and the angle contained are known, I will be able to do that by using C is equal to square root of A square plus B square minus 2AB cosine theta. That is called the cosine rule. Have you used it in the past? Question? Somebody's got a question? No. Alright, C is equal to square root of A square plus B square minus 2AB cosine theta will help you to get C, the third side.
Yeah.
So let's go here. Here's your triangle. Do you know two sides for sure?
Yes.
Which ones?
50.
And do you know the angle contained?
Yes.
How much?
40.
You already know that because I gave you this angle, so you should be able to figure out the angle contained. So when you know this side and the angle contained, can you find the third side?
Yes.
Go ahead. That's called the cosine rule, so it just straight away helps you to find the third side. So we have A, so 50 square plus 70 square minus 2 times 50 times 70 times cosine of 140, close. Okay. And what is the answer?
112.9.
How much?
112.9.
Yeah, looks right? So when you get an answer, just look at your picture. And is it agreeing with that? So length looks like that answer. And if it is not appearing to be null, this one comes out 40 meters, then you say, no, that doesn't look like 40 meters. I better check my calculation again. So that is what I say, use your references. So when you do a calculation, you don't blindly put that answer down. Go back to the picture and say, is that something that is acceptable? How much is it?
112.9.
So 113.
Oh, yeah, it's small.
So 113 meters is what you get as this length, this resultant. Is everyone okay with that?
Yeah.
Everyone has plugged in the answer question, this thing, and then you got the same answer. It is likely that some of you did not get to the answers. Some of you got something in 90s. It's possible. If you plug things wrong, or if you don't include a certain bracket, you are going to get a different answer. So operate your calculator properly and get it done. So we got this one as 113 meters. Is that the end of the story? No, we need to find what?
The angle.
The angle. For that, we use another rule called the sine rule. I guess you must have done that one. So write it down. What is the sine rule supposed to help you with? Write down the statement so you can actually understand what it is. Sine rule helps you to find unknown sides and unknown angles in any triangle. Sine rule helps you to find unknown sides or unknown angles in any triangle. Write that statement down so that you have a concrete idea. What is cosine rule supposed to help you to do? What is sine rule supposed to kind of be used for? So what is sine rule? It is a rule that can actually help you to find unknown sides and angles. Simple. So in any triangle, suppose you have any triangle. Suppose you have any triangle. If this side is A and the opposite angle is A. If this side is B and the opposite angle here is B, and if this side is C and the opposite angle right there is capitalized C. So I put all the angles as capitalized, all the sides as small case. Then, now all these things can be proved. Sine rules and cosine rules are all provable, okay? But right now I'm just stating it. So the side over the sine of the angle is always going to be constant. The side over sine of that angle equal to the side over the sine of that angle. That is called the sine rule. So it helps you to connect sides and angles. So if you know A, if you know B, and if you know this capital A, can you find capital B? Yep. Or if you know A, and if you know C, and if you know this capital A, can you find this C? So it kind of helps you to, so what does this mean? This means this is equal to this, or this is equal to this, or this is equal to this. That's what it means. Now let's go back to our triangle and find out, what are you trying to find out? This, right? If you're trying to find out this, that's one of your angles that you want to be in. So which means the opposite side is going to be included. So I'm going to consider this to be one of them. So 70 divided by, what is the angle? Sine theta. Now you need one more side and the corresponding angle. Which side do you know?
113.
You know 50 here, but do you know this angle?
No.
No. So ignore this. You know this side.
Yeah.
And you know this angle. So go for it. 113 over sine 140. This angle.
Yeah.
And then find out, so cross multiply this and you get 70 times sine 140. Everyone must do this on the calculator. Divide by 113 now. How did I get this one? I cross multiplied and I singled out sine theta. Yep. 70 times sine 140 is 113 times sine theta. So what is sine theta alone? It is that divided by 113. You know what is cross multiplication? So cross multiply, write it down, and then single out the sine theta, and you get there. So how do you find the theta,
Inverse sine.
Jackson? How do you find this theta? How do you get the angle? Press second function,
Second sine.
second function sine, so it will come out like this, and then put this entire thing. This is our ratio. This is our entire ratio. Put it there. 70 sine 140 over 113, and that should give you the angle. But make sure your calculator is in the degree mode. We will not use the radian mode at all. So at all times, double check on the mode and see if it is the degree mode.
So
How much is it?
3.5.
How much?
23.5.
Yeah, that looks right? 23.5 looks agreeable. Look at that. If that's 40, a little less than that is what this is. So 23.5. Where?
West.
23.
North of east.
No, it's
I never said the plane was going east or north and all that.
up of horizontal.
Above horizontal. Since I didn't mention anything about north, east, and all those things, you just have to say what I referred to. What is 40 degrees? Above the horizontal. So your answer is also going to be above the horizontal. So if it took off from here itself, which it can't, of course, imagine it took off from here, add 23.5 degrees and went 130 meters, it would be right there, at the right spot. Okay? Do you understand this? Application of cosine rules and sine rules. Yeah.
Why is it 70 over sine theta and not 50?
Because I know I want this angle, so I need this. And what is the opposite side of that? Is 70.
Okay.
So that's why I said this is one side, and this is the angle that is right opposite to it.
Alright.
So yeah, you got to be a little careful not picking up the wrong numbers. So again, can you find this angle and then say that as your angle for the resultant? Not really. That is our destination. You cannot refer to that angle. It's always good to say from the source, from the origin, right? Now what are the, okay, this is wonderful. For any angle, you can get the answers. All you have to do is just cosine rules and sine rules, and that's it. You get it. And you can see that equation for cosine. What if look at this. C is equal to square root of a square plus b square minus 2ab cosine theta. What is going to happen if the angle is 90 degrees here?
Oh, that's going to be 0.
So cosine of 90 is 0. That means this whole thing turns out. So what is this equation then?
A squared plus b squared.
C squared.
What is
So
that?
you just find the hypotenuse.
That's Pythagorean theorem. So Pythagorean theorem is just a special case of a cosine rule, basically. So when the angle theta is 90, then your equation shrinks to that, which is basically your Pythagorean theorem. Okay? Now that means this can be applied for any angle, anywhere. What is the disadvantage of this method? You may not be using this method at all in future.
It takes a long time.
It takes a longer time, yes, and then
There's no mess up.
there's
Yeah,
chance
this
of messing
one's
up.
small.
Plus, the other thing this one is incapable of doing is this can only do the resultant of only two vectors at a time. Right? This can only do two vectors at a time. Suppose I give you 10 vectors and I ask you to do the resultant. In the last example I gave you 4 vectors, right? Scale drawing. Like that, if I give you 10 different vectors and say, okay, what's the overall effect? Now if you're going to use the cosine rule, you have to take the first one with the second one, find the resultant and the angle, and then use that with the third one and find the new resultant, and then that with the fourth one, and then find a new resultant, and you keep doing like this 10 times, and finally you end up with getting a wrong answer. Even if I do it, I'll get it wrong. Because you're doing 10 times mixing up cosine rules and sine rules, there is a chance that I miss something somewhere. A little bit. And that little bit is enough to mess up the whole problem. So the disadvantage of this one, the cosine rules and sine rules, yeah, for 2 vectors it's fine. But even for 2 vectors, I won't use this method. I just mentioned it to you because that is a possibility. Okay? So I've seen some students sticking to this method just for 2 vectors, and they're pretty okay with it, fast. There's nothing wrong with using it, but there is a much simpler method. So I mentioned about scale drawing, I mentioned about calculation method, which is using cosine rules and sine rules, but then the best method is method of resolving. Method of resolving. Resolving vectors. And that's the best method. And you will use this method in so many chapters. Because wherever you come across with vectors and you have to find the resultant, the easiest way of doing it is this. Now, what's the advantage of this method? Even if there are 10 vectors, you will almost take the same time as doing 2 vectors.